Waste a lot of time. I just would like to introduce you James DeMeo. He's already in the pole position, giving us a nice introductory talk about Wilhelm Reich. It's all yours.
Good morning. Two things to start off. Can you hear me?
New battery.
Okay, testing 1, 2. Hey, that's good. Great. Beautiful morning. First, thank you so much, Jerry. Wonderful conference, and I appreciate the invite, and, as always. And thank you to all of you for your kind words and attention. Another small preliminary on the question of Wilhelm Reich and orgone energy and cloud busting. This is really quite serious stuff, and yet if you go to Wikipedia or if you go on internet, you're going to be introduced to the most god-awful collection of nonsense that you've ever seen in your life. So I just want to make that as a preface. Wilhelm Reich's work, you want to consult the original writings or websites that stick close to him, like my own is here, orgonelab.org, and there are a few others, the Wilhelm Reich Museum, for example. So I just want to, a word to the wise, this is not unfamiliar to people who work in the water research either. My talk about restoring life properties to atmospheric water, a new method for ending droughts. I've been doing this. This has been a major part of my work starting in the mid-1970s. And, let me get my clicker here. Okay, this is Reich. The Reich Cloudbuster. He made the discovery in the 1950s based upon prior work that he did on the discovery of a specific life energy. He discovered life energy in living organisms. He called it the orgone to keep it preserved with the idea of organic or organism. And later discovered that there was an expression of this life energy out in nature in the atmosphere, and later with experiments in high vacuum, he determined it also existed probably in cosmic space as well. So it's a very far-reaching set of ideas that he developed and got him into trouble with the Food and Drug Administration. As most of you know, he was attacked and had his books burned by the food and drug people. But enough copies survived that there's been a resurrection of his work over the years. I'll just show you a couple of his publications on this weather issue, the atmospheric component of his discoveries. He did research in the Northeast United States ending droughts with his Cloudbuster device. You can see him here. And also in the deserts of Arizona, proving that you could also use this method to green deserts. And his theory is different from most of what I think is commonly referred to today in mainstream science. His theory was more grounded on the old idea of cosmic ether. So he's talking about this life energy that fills all space, much like the ether of space, and that it has a mutual affinity to water. This is very interesting. He says the orgone energy has a mutual affinity to water, meaning water is attracted to it, and it is attracted to water. And all kinds of theoretical, philosophical things come from that, but that's for a later lecture. He determined that the orgone energy had a negative entropy. It had a negative electrical charge in higher concentrations, and that as it moved through the atmosphere, this is a fluidic kind of a thing, not a static, stagnant ether, but something that moved, like streaming protoplasm moves in an amoeba, that it drags the atmosphere along with it, creating wind. And also that it had different states of excitation. It could be very excited and agitated, or it could be relatively smooth and calm in a normal state, and then under certain states it could freeze and become stagnant and immobilized. So he talked about these different states of this energy more than just having discovered the energy itself. In the context of his weather research, We look at the blue field of the atmosphere or the blue color of water as an expression of the orgone energy charge in the water. And I've given some presentations that give a little bit of legs to that idea with my own water research. Jet streams are produced by this theoretical understanding by streams of the orgone energy coming down from space and dragging the air along with it. There's an interface between the orgone energy itself and the material structure of the air. And this gained a big support with the discovery of the upper stratospheric winds, which are now seen blowing at the extreme edges of the Earth's atmosphere and then downward convecting energy into the upper part of the troposphere. So there's all kinds of new discovery coming out in that area. At any rate, let's just go on from here. I've got a number of slides. I started doing this research in 1977 as I was a graduate student at the University of Kansas, and I was very concerned about drought and desert spreading, and the big starvation episodes were taking place in Ethiopia and other places like that in the Sahel of Africa. So I thought, well, my gosh, you know, all these other efforts for greening deserts and so on have failed, all for the most part. That failure was written over every single effort for stopping the advance of deserts. So this seemed like a natural, you know, you make a lot of rain and suddenly you overcome the whole issue of stopping deserts because you just convert them over to something a little bit greener, perhaps. That's how I got interested in it. I did work at the Geography Meteorology Department at the University of Kansas, and at first they were rather alarmed at my proposals, but they were open-minded. They said, okay, well, let's give it a go, give it a try. And that's how I started getting into this particular line of work. Here's me when my hair was a little darker, more of it. This is 1978, and this big instrument in the background, it's a cloudbuster that I built with a friend of mine who had a machine shop, and we went out there and we built this thing. And I called it Icarus, is the name of the cloudbuster Icarus. And I did 2 years of work on that subject, 77 to 79, and which I'm going to talk about here. The field trials were held at the farm of Professor Robert Nunley. Some of you may know him. Anybody know Bob Nunley? Very friendly guy, lively guy who opened many doors for me at the university. And the study itself was reviewed by the KU department faculty and to make sure I had a very good protocol so we could really determine what was going on with this thing. One of the protocols was a test for cloud dissipation. And this idea is that the aggregate form of orgone energy in the atmosphere, it can be stretched out and thin, in which case there are no clouds. But if it starts to bunch up or becomes a little wavy, then you get clouds growing in the inflection areas of this, or the discontinuity regions of this medium. And if you aim the cloudbuster right at the core of the cloud, the idea is you're pulling the orgone energy charge out of it into the water in which the instrument is grounded, and then the cloud naturally dissipates. So if the orgone field is what makes the cloud, and then it attracts the water to it to build up the charge. And what you see here is in this, you see these are time-lapse photos about 1 minute apart. And after the 5th minute, we would flip a coin and decide whether to test or not test, but continue filming. And in this one, this is one of the test sequences. You can see the cloudbuster is aimed at that cloud right after this 5th minute. And you can begin to see it's already dissipating fairly quickly. And then we switch over to this other little one, and that's gone too. I did a whole series of these cloud dissipation trials, and they confirmed what we expected. Whoops. I'll just show you a couple of things here. It didn't always show a clear dissipation, but sometimes the clouds would change in patterns. Here, like you couldn't look at, these are cross-sectional areas of the cloud which were digitized. So if you look at them, you can't really see too much, but when you graph it out, you can see something is going on that right when the cloudbuster is aimed at these clouds, they begin to change in their dynamics. I did a whole set of those photographs, and there was statistically significant evidence that these clouds were changing at that 5th minute, right after the 5th minute, as opposed to any other minute. But I like clouds. I wasn't too happy about dissipating them, so I did also a study on the making clouds or increasing clouds. And that's what you see here is a typical sequence for about 5-6 hours of work on a particular day. There were 12 of these particular experiments were done, and you can see here the rather regular progression ending up in nice Kansas thunderstorms. And this is the data graph from all of the Kansas data, either 270-something stations for the whole state. This is 6 stations with an hourly rainfall. And what you see here is hourly percent cloud cover before the operations, 3 days before the operations, the day of operations, and 3 days after. And so you can see here the clouds have a natural pendulation on the 24-hour cycle. And then when the cloudbuster is activated around noontime, in the middle of the test day, there's a disruption of a perturbation of the percent cloud cover. It stays up at higher levels rather than dropping down as it did previously. And you also get a nice peak in rainfall there with a secondary peak about 2 days later. So there's was pretty good evidence from this study. They gave me my master's degree for doing that, and it was had a nice simple title: Preliminary Analysis of Changes in Kansas Weather Coincidental to Experimental Operations with a Wright Cloudbuster. And it's still out there. I actually published it as a little book. You can get it on Amazon if that sort of thing interests you. And it's interesting that the appendix document to this booklet got me in trouble more than the data itself. The appendix was called Evidence for the Existence of a Principle of Interconnecting Evidence for the Existence of a Principle of Interconnection in Nature. In other words, that there's something that connects other things together in nature. And so I gathered together all kinds of evidence there. And I happen to mention that if this is true, then Einstein can't be true, because his whole thing about anisotropy in space would be blown apart. So that got me in big trouble with the physics department. There we go. Now, the next thing I did was in '89. I kicked around for about 10 years teaching in the universities and got in trouble every time I opened my mouth about this. So about 1988, '89, I quit the university system and went private with my own institute. But before I did, I got some funding from a few friendly people, and we went out to the deserts of Arizona. Come on. Oops. And tested this out on 5 pre-announced dates, and they were about a month separated. And the study area was a very large area of Southern California, Southern Nevada, and all of Arizona. Because the prior work showed it worked over the whole, had effects over the whole state of Kansas, so this was not an unreasonable study area. And they were announced to the Federal Office of Weather Modification, which was a part of National Weather Service at the time. And so I went out there and I did these operations, just a few hours of work or a day of work, once every month approximately. It's set up near Blythe, California. Anybody ever been near Blythe know what a desolate area that is. And I'll point out something here. Here's the atmosphere in the typical pre-operations condition. You notice that there's this obscuring haze. And here's the situation after the operations. Here you can see this little mountain here is the same one here, just to give you a nice contrast. And that kind of clarification of the atmosphere was something that Reich noted very early on. He talked about the stagnated quality of the atmosphere in the desert regions. This is something that the classical meteorologists would call the atmospheric inversion layer, and it's known to block the development of clouds and rainfall. So what was being observed is that this inversion layer phenomenon, or the haze layer, or the stagnant orgone layer, as Reich would call it, was being dissolved and made more motile and transparent by using the cloudbuster. And I can't for the life of me figure out how that could work if it's 100% composed of dust particles or aerosols. But if it's an energetic phenomenon and somehow the energetics of it are changed in ways that we don't quite understand, then the clarification of the atmosphere would make some sense. In any case, once this was done, we would see increases in cloud cover and rainfall over this whole large area. Here's another picture of the atmosphere. Again, this haze layer goes up to something like about 2,000 feet in the Arizona deserts. Here you can see after working a few hours, it's clarified. You get these high cirrus marking the intrusion of the jet stream into the area. And here's the analysis of the 5 operations put together for those 424 weather stations, the daily rainfall amounts. These are the 15 days before. This is the day of the operations for all the operations combined and averaged together. And here's the 15 days after. You can see there's basically a doubling of the rainfall quantities for about a week after these tests were made. And this really confirmed Reich in a big way. And I thought, my gosh, you know, this is going to open it up quite a bit more, and there'll be some greater interest. And the results were kind of interesting that the NOAA Office of Weather Modification subsequently claimed that they had never been sent any of the documentary telegrams or anything that I had sent them over the years, which they had stupidly sent me letters saying, thank you very much for your materials. So it looks like they just burned everything or threw it away, which is, by the way, a criminal offense. It's a felony to destroy government documents, I've subsequently learned. Anyway, they later denied having been sent anything, and the Airland Society, which is the premium group dedicated to arid lands and the problems of people living in arid lands, they, when I gave my presentation on this, they scheduled me on the very last day of the conference, a special session when everybody else had gone, and it was me and one other guy who was presenting, and our girlfriends, and nobody else was there. I can laugh about it today, but it's really tragic, you know. So there was no official interest at all. Israel operations were done subsequently, 91, 92. Under a condition of 3 years of acute record-breaking drought, conflict potential was very high over water resources. This was funded by a private initiative, but we got full permissions from the Israeli government. And they actually sent a representative from Mekaroth, their hydrology department, to sort of cut red tape and get us access to places where we could set up around the country. And worked 10 days at different sites from the northern to the southern parts of Israel, and the results were really quite spectacular. Here is the stagnant haze, and in this case the haze layer goes up to about 5,000 or 6,000 feet. And that's typical during the Saharan desert fringes. And again, this is something that's quite obvious and repetitive in terms of its, where you'll find it under drought conditions or desert conditions. This is getting close to the Dead Sea. This is Lake Kinneret before any operations were done. That's the Sea of Galilee. And here's the instrument. It was a fairly simple thing we built while we were there. And this dotted line you see here, I'll reference that momentarily. This is the Jordan River, or what was left of it at the time because of the drought. Extremely low flow. This is using the device, setting it up. And here you can see this has been working for a couple of hours. You can see that this area in the front area looks relatively good. Notice this little dock here, I'll reference it. That's about 2 meters of distance there, a little bit more. And after a few hours, you begin to see on the other side the other bank of the Kinneret begins to show up. And we also worked on the Dead Sea and the Red Sea near Eilat. And about 6 days after the work started, this rather large cyclonic storm formed in the eastern Mediterranean and started moving eastward and amplifying as it moved. Usually what happens is by the time they get to around Italy, certainly by the time they get to Greece, they begin deviating off to the northeast and therefore leave the eastern Mediterranean in a condition of drought. In this case, it went straight east and arrived on the coast of Israel and brought record-breaking rain, which they had not seen in many years. Here you can see a percentage of rainfall for map for that epoch of November 27th to December 7th, 1991. And they called it the biggest rain in 50 years. This is from the same time period in the Jerusalem Post and so on. So I thought, well, this is going to open the doors to, people's eyes will be open, and this is going to be great. You know, we'll get a project going. I had a project outlined for them to green the Negev Desert. You know, go to the Negev Desert, green it, make plenty of rain for everybody, not just the Israelis, but everybody. You know, farm and agriculture will boom. Everybody will be peaceful and happy, and other naive ideas I had about that. But what happened was, let me finish here. Yes, here's the February 92. We went back a few months later. You can see the dock area. The water has risen up by a couple of meters. Maybe that doesn't seem like much if you look at Lake Mead. You know, a couple of meters is something, but it's not a great deal. But for a small country like Israel, that is a big deal. And they had been using every pump they had to pump water into the groundwater. Tiberias on the Sea of Galilee almost flooded, so they had to open the Degania Dam to let fresh water go down into the Dead Sea, which is an unheard of thing. They don't rarely do anything like that. And they even removed the fish nets because it was inhibiting the flow of water, because they didn't want Tiberias to flood. So the Dead Sea got a big shot of fresh water, and Lake Kinneret filled, and all the reservoirs underground were being pumped. And there were, out in the Syrian desert, there's wildflowers blooming, and old dead trees came back to life. All kinds of interesting things. I wrote it all up in a report. And here's the Jordan River. Here's that dotted line I referenced earlier. And the landscape's all greened up very nicely. Record-breaking rains across the Negev, Syrian desert, snow seen for the first time in living memory in the mountains around Eilat, fields of wildflowers, and so on and so on and so on. And here's the Israel rainfall data from their 13 stations, averages of their official records. And you can see that here's the time period of our operations, and then you get this pulsation of rains coming in. This is like a heartbeat. Wright described this natural pulsation of rains like a heartbeat. And this is not a device that you use on a permanent basis. It's like acupuncture, you know, you get something moving again, and then you stop. And if you get it going, it's like a natural heartbeat. It just keeps going on its own. The official reactions were they said that it couldn't be cloud busting because Mount Pinatubo had erupted on the other side of the world 6 months earlier, and that was the reason. I'm serious, that's what they said. And I subsequently did work analyzing or reading somebody else's paper on weather conditions globally after Mount Pinatubo erupted. And globally, the world cooled off a little bit, and dry conditions were more global after Mount Pinatubo. So that's really ironic that the only place that got really exceptional rains during that same period after Mount Pinatubo was in Israel, but they somehow came to the opposite conclusion. So that was in 91, 92. Then there was another project. I'm going to rush through this because I'm running out of time here. This was a 5-year project that was funded by the government of Eritrea. And Eritrea is this little country in the area of the Red Sea, northeast corner of near the Horn of Africa here. And it's very high elevation. Here's the road from Asmara, Eritrea, down to Massawa on the Red Sea coast. And it's a very rugged area, people, subsistence agriculture in the hinterlands. And again, this stagnant hazy quality dominated everywhere. Worse than I had ever seen it in my life. And this was where we were headquartered at the Agricultural Research Center in Asmara. They opened their doors to help us in every way possible, although we had very minimal funding just for our expenses, basically. We constructed a device there, took it out into the countryside. Periodically, we would stay in Asmara, go out on these expeditions lasting a day or two or three, and then come back. And this is one daily sequence, typical. We would set up a big reservoir like you see here. This reservoir is actually down by about 4 or 5 meters down from what it should be. About 2 hours later, you see the rainfall comes back and then begins to kind of navigate itself towards where the cloud busting instrument is located. And we get these rather good rainfalls. And this is typical of what they're accustomed to in these areas. They called it deluge. When they were saying, oh, there was a deluge, and I was shocked. I said, oh my gosh. He says, no, we like this. We like this. This is what we need. So it was their word, and they're quite happy with it. And the older Eritreans said, this is like the rains we remember from 30 years ago. And 30 years ago, there was a huge drought. I mean, there was a drought across most of the Sahel that lasted from around 1962 to 1994, which is when we did our first year of work here. And I'm going to rush through this. This is, again, 5 years of work, so I can only give you some selected things. But this shows you the configuration. Here's Eritrea. This is the moisture flow. It comes from the Gulf of Guinea, way down over here in West Africa. It flows north like so, and then it gets into the Nile River drainage basin. And from here it would get caught up into the tropical easterlies, which would blow the rain across this whole area. So there was a very good enriching rain, not just for Eritrea, but for the whole region. Here you can see one typical satellite image. Eritrea is somewhere right in here. And this is the rainfall precipitation index for the Sahel produced by the National Climate Data Center. And here we have 1994, the first year of our operations, and it was the first year of normal rains, above normal rains, in quite a long time. So here's this 30-year drought period that they had suffered through, and then we did our work at that point. And the biggest result we got was in 1998. Actually, it was predicted to be an El Nino year, so drought was anticipated for the whole Horn of Africa. I said, well, maybe we better build more than one of these instruments. We built 3 of them in total and put them out into the field. They were coordinated in operation by radio telephone. And I had a couple of teams of native workers who would do what I told them to do. I just had to give them the orders, and they were judicious in carrying out things. And the rainfall in that particular year, these huge peaks is something that they had not seen in a long time. You get these huge peaks in rainfall. Even with the cloud busting, the normal rains weren't quite that much as what we had with the 3 different instruments employed. At any rate, after the 5 years of work, we were not able to get rainfall data for a couple of those years, 1999, for example, and the 1994 data was not fully available in a daily organized form, so we only had about 3 of those years put together in this data analysis. But you can see here that this is an aggregate of 6 different epochs of work. This is the date when we would start working. Here's the 15 days before, 15 days after. You can see that the after period has an increase in rain of about 50%. And the probability coefficient on that is pretty good, about 0.0042, which is not bad. And so I was very happy with that. Unfortunately, with all the bounty of rain, their food supply imports reduced, so they were growing a lot more food and everything, and unfortunately all the governments of the area started pouring money into weapons, and they started buying bombers and tanks and machine guns and bazookas and God knows what else. And the next thing you know, they're in a big shooting war with the Ethiopians. And Ethiopian bombers are bombing the Asmara airport, all the NGOs are running for cover, and so I told my team, I said, that's it, we can't, we're driving around with this thing that looks like it's got tubes, and you know, some guy in an Ethiopian jet is going to see us and come down and drop a bomb on our head, and I said, forget it, let's go home. So we were, the country then went Stalinist. That's another lecture on that alone. So 1999, last year, I went there all by myself. I did a little bit of work, and then we went home. But the big rains continued, and for another couple of years. And we were so depressed at this result. My God, 5 years of work, I thought it would open up again, you know, and again, a result socially that was going to close down any possibility for further research. But then this unbelievable thing happened. This article about new lakes in the Sahara appeared in the San Jose Mercury News. A change of biblical proportions is washing across the Sahara Desert. For the first time in 6,000 years, new lakes have risen from the sands of southern Egypt. Nile River, swollen by unusual rainfall, is spilling over the reservoir behind the Aswan High Dam. As expected, the water flows through an arroyo into the Overflow Lake, but the deluge has continued, and 3 more lakes now unexpectedly dot the desert. And I was just flabbergasted by this, but in looking at it, it wasn't quite so unbelievable after all. Here you can see these overflow lakes, which appeared starting approximately 1998-99, when we were doing that big result of 3 different cloudbusters. It says the lakes hold about 700 billion feet of water, 1/4 of the Nile's total water flow, okay? Annual flow. Anyway, here I showed you this earlier. Again, the moisture that was raining down in this whole area of the Horn was flowing down the Nile, and that's where it filled the Lake Nasser for the first time since it had been built in 1968, I believe, was when it was first opened up. So here is a NASA image from October 2000. It had been a little bigger in 1999, and I show you the 99 images flashing there. So the major Nile flows began during this project, this 5-year project, particularly in 1998, continued through about 2001. Here we are today, 2015, they're drying up, they're almost gone. So this is a somewhat depressing thing about the lack of it catching fire, so to speak, in the social consciousness. But on the other hand, it's a hopeful message of the possibilities, my God, the possibilities. Here's Asif Al-Habti Michael, the head meteorologist for Eritrea Civil Aviation. He opened a lot of doors for me, for our team. That's me again. And I want to thank all the people who helped us in that project. Even though none of them are here, it was a multi-person project. And I thank you all very much for listening.
Thank you very much, James. You still would have 1 minute left, but that's a perfect length. May I take the privilege to ask the questions first? Thank you. Since I have the mic. How do you determine whether it's cloud busting or cloud generating? Number 2, this year is forecasted El Niño year, so could it be a tool to modify that?
Well, because normally in weather modification experiments, they select a control area and a test area, and then you compare the two. But the effects of this are so widespread, we cannot do that. So what we do is we set up a before versus after scenario. And so all I can do is point to the result after has been almost systematically, like what you see here, of large increases in rain, usually slightly above the normals that follow the operations. And yeah, I have to go on the track record, and I can't really answer too much beyond that. So, El Nino? Gosh, well, I suppose it depends. I'm trying to get a big project going in California for the last 4 years, but it's deaf ears mostly to it. So, yeah.
Jim, as I presented about the Earth's negative charge, and so if you have something connected to the Earth with heavy wires, as you do, and pointing up, it's kind of like a lightning rod that is connected to a big source of negative charge. And so, you know, because charges tend to accumulate at sharp points, I would imagine, not sure, I would surmise that at the tip of those rods you might have a huge negative charge, and if so, that would induce positive charges from the atmosphere to gather around. Do you think it's possible that I mean, those are logical steps, that the gathering of positive charge may have something to do with the coming of rains?
It certainly is something that ought to be tested, but I'll tell you, when this question came up early in my work, and the arguments for a lightning rod type of effect seem extremely limited in terms of distances. But again, we're not grounding to Earth with pointed metal. It's hollow metal tubes grounded in water. So there's some, and it has to be living water. I've tried this in stagnant water where you have dead fish floating, and it doesn't seem to work. You have to have some vital, lively kind of water. And who knows, maybe this is part of the EZ question as you've been researching, that lively, vital water with a blue color. Who was it that showed that wonderful picture of the lake, of the area in Finland with this blue glowing lake overflowing with thousands of gallons of water? That's the kind of water that it really works well in.
Yeah, that would have negative charge, I suppose.
Yeah, I would think, yeah.
Thank you. Hello? I'm a little bit confused about the time frames. First, you pointed out that it is like acupuncture, that it's a single use, it's a single treatment, and then on the Eritrea example, you spoke about 5 years of work. So, what is the time frame for a single intervention, roughly?
Well, the work in Israel, for example, started, and 10 days later we were finished, and this big rain came afterwards. In Eritrea, we went there twice a year, one time in mid-June, I believe, and later in early September. So we would work it there again for a few days, and then the results would start to come. So each of those two epochs each year were showing this kind of increased pulsatory and rainfall activity afterwards.
So it's a couple of days.
Within a couple of days, yes. Starting.
So, any further questions? Yes.
At the beginning, the first two things you showed, where first you broke up some clouds, and then you formed some clouds. I was wondering what you do differently between those two cases to decide which results you're going to get from the...
Well, the dissipation trials are fairly simple. You just find a cloud that meets the criterion of isolated cumulus and aim right at it and follow it and track it, and you get this result. For the bringing rain, it's more complex. It depends upon local climatology, meteorology. It's different in every location, so you have to have some... my study at the university was in the Department of Geography and Meteorology, so I had a lot of background knowledge in weather science to gauge the classical kind of parameters and then integrate that with what Reich was saying. So.